Good morning, 10Cs, or good afternoon, or good evening, depending upon when you're watching this. Here we go, another lesson today. So the first couple lessons, a little bit that we've talked about, sort of background information, practicing some skill sets. This is the factors and products, which is really just a different way of saying polynomials unit. Today we're really going to get into polynomials. Some of this review from what you've seen before, so it's not going to be overly stressful, kind of a nice little lesson, give you something to work on today and practice a bit. So here we go, adding and subtracting polynomial terms. Now, you will find in this booklet there are at times information and questions and pages that use the algebra tiles, which were a significant part of the junior high curriculum. However, in high school, we don't really focus with algebra tiles. At times, I will talk about them, use them just to prove a point and to help you to see what's going on in the math, but it's not essential material. You will not be tested with algebra tiles. But just for our sake, at times, there are really three types of tiles. You have the x squared tiles, because they are x by x wide, so that means it's an x times x or x squared. You have just x tiles, a unit wide, 1 unit wide, x units tall, so 1 by x is an x tile, and then you have a unit by a unit, which makes it a unit tile. Two different colors. I'm going to use the dark as positive and the light as negative. So these would be negative x squared tiles, negative x tiles, and negative unit tiles. We will use them a little bit, but don't worry about doing all of the algebra tile work in the booklets unless I discuss it and tell you its importance. So what we're going to do today is we are going to combine terms. Something you've seen before, not overly complicated, but let's just get back in the groove of the polynomial work. So if I wanted to show what combining terms look like, we have here, from yesterday's lesson, 4 terms. We have a 2x term, a 5, 3x, and -1. Well, I can show that with tiles. 2 positive x tiles. That's what 2x is saying. 5 positive unit tiles. So that's what this is telling us we have. Each term can be represented by tiles. Please don't put signs in between tiles. Signs are totally unnecessary because signs get described by the coefficient. This is positive 2x tiles. This is adding positive 5 tiles. We now want to add positive 3x tiles. So I need 3 more x tiles that I can put in for this polynomial expression. And now I have to be careful because I want to finish with 1 unit tile, but now it's a negative tile. So watch your signs. Now I can bring in a negative tile. So there's what that expression looks like with tiles. 2 x's, 5 units, 3 more x's, and a negative unit tile. But what we can do with these is we can simplify. I don't need 4 separate terms because some of this stuff goes together. But what's going to go together? The unit tiles go together. They're the same thing. Different signs, but they go together. The x tiles go together. So when I take a look at this, what I'm now looking at, simplified form, is I no longer need 4 terms, because what am I left with? Well, if you look here, we have 1, 2, 3, 4, 5 x tiles. What else do we have? Well, remember, a positive and a negative of something, additive inverses, zeros, cancel out. So what else are we left with? After we cancel, we're left with positive 4 units. So this 2x plus 5 plus 3x minus 1 can be simplified by combining the terms to become a binomial 5x plus 4. So there's what we're doing to combine tiles. However, let's take a quick look at what we've done if we didn't have tiles. Well, which tiles did we put together? Well, we took the two x's and combined the two x's with the three x's. Why? Because they're the exact same shape. Well, 2x and 3x are like terms because the like terms have identical variables and exponents. In this case, the exponent I could say is a 1 on each, but identical variables and identical exponents create like terms. So we put like terms together. We also had 5 positive tiles and 1 negative unit tile. And we were able to put those together. Why? Because they're the same shape, same tile. And again, what do we have there? We have a constant of 5 and we have a constant of -1. Again, like terms. They have this identical variables by not having variables. So in this case, there's our like terms. Once you identify like terms, what we want to do is combine these. And how do we combine the like terms? We add or subtract the coefficients on each term. So we see that in this case, we have 2 x's and 3 x's. Well, 2 of them and 3 of them leaves 5 of them. We had 5 constant units and a -1. Well, 5 take away 1 leaves us with +4. So what we need to do, combine these by adding or subtracting the coefficients, but we leave the variables the same. So that's what we're looking to do with tiles. Let's take a look at another one. 2x squared minus x squared minus 3x plus 4x minus 4. Well, if I wanted to show this with tiles, I have 1, 2, 3, 4, 5 terms. Start with, I have 2x squareds. There's my 2x squareds. That's what that term is. Then I have a negative, x squared. A negative x squared term. So we do what? I don't need to put a subtraction sign in. I don't need to say subtract an x squared. Because it's white, we know that the white tiles are negative tiles. Remember, an x squared by itself is like saying I have 1 of them. So if you want to put that coefficient of 1 in, go for it. We then have -3 x's. Well, 3 x's that are negative, there we go. -3 x tiles. The next term is +4 x tiles. So I need +4 of the x tile. There's +4 x. And my last term, watching my signs carefully, -4 units. So those go there. Now if we look, term 1, 2x squared. Term 2, -1x squared. Term 3, -3x. Term 4, 4x's. Term 5, 4 negative unit tiles. Well, let's put together the things that we can. If I look at the expression to start with, I lost my coefficient of 1 here. If I take a look here, well, I see that x squared is the kind of term that is. Do I have any x squared terms besides it? I do. So 2x squared and -1x squared, those are like terms. And if I take a look at the shape of them, I see that all of my x squareds can go together. Well, what else do I have? I have x tiles. I don't worry about the -3 This is x term. Do I have another x term? I do. So there's another like term because I can see these are the same shape. They're all going to go together. So there's all of my x's. Group your like terms. Identify what's like. And then finally, I have 4 negative tiles. There's nothing to combine those with. They're the only term that's a constant, so they stay as is. So now I mathematically want to combine these things. Well, mathematic-wise, 2 and negative 1 leaves us with a 1x squared. And I can see with the tiles, a positive and a negative go together and make a 0. So I can get rid of those. There's my 1x squared in my final simplified form. I then have negative 3x's and positive 4x's. Well, negative 3 plus 4, well, that's a positive 1x. So I take a look. Look at my pairs. I have 2 positives, 2 negatives, additive inverse. They cancel each other out. I have another positive negative pairing. They cancel each other out. So what's negative 3 and a positive 4 leaves us with positive 1x tile. And then finally, my negative 4, nothing to combine them with. There's my simplified. In this case, we're left with negative 4 unit tiles. There's my simplified polynomial. X squared, the 1's not important. If you have it, it's not wrong, but it would never be on a multiple choice exam. X squared plus an x minus 4. There's the simplified form. So that's what we're looking to do to combine terms. So let's do it without tiles, because tiles are helpful to see why we do it, but let's walk through the steps. Identify your like terms. These are x squared terms. They're like. I then have an x term, and I have another x term, because I don't worry about the signs. I don't worry about the coefficients. I have a 3 and a negative 1. I don't care about those right now. They're like terms because they're both x terms. So if I have 2x squareds and 4 more x squareds, add and subtract the coefficients, do nothing to the variables. 2x squareds and 4 more x squareds gives me 6x squareds. 3 x's and a negative 1x, well, 3 and negative 1 leaves me with 2 x's. And at that point, I now have the simplified polynomial. If you happen to combine your x's first, 2x plus 6x squared, it's the same thing. Two terms, a 6x squared that's positive, a 6x squared that's positive, a 2x that's positive, a 2x that's positive. Order doesn't matter as long as you have the right terms with the right signs. This is a better way to write it because usually writing the terms with the larger exponent going down to smaller exponents, that's normally how you'll see it written, but this particular binomial isn't incorrect. So here we go. Try this one on your own. Pause the video, do it quickly, and then we'll talk. Identify your like terms. X squared, x term, a 1x and an x term. Well, combine those. 2 and negative 3 is negative 1x squared. And then the 1x and negative 2x's leaves me with a negative 1x as well. Best way to write this, we don't need the coefficients of 1. Short answer, I would accept this, but a better way to write it would be to drop the coefficients of 1. They're really not necessary. They're assumed to be there. There's your simplified form. Now, big change here. We have lots of terms. We can hopefully see that some of them are like. What can we do with those? Well, we add a step. Distribute the sign in front of each set of brackets. And then we go through the same steps. So what's the sign in front of this set of brackets? Really, it's a positive. There's nothing there, so we assume it's a positive. So what's a positive going to do to these? Absolutely nothing. X squared plus 4x minus 2. Well, we have another positive sign in front of a bracket. So that positive has to affect every term. What does a positive do? Absolutely nothing. But we can eliminate the brackets by distributing. If it helps, we can always put a 1 with our sign. It's like we're multiplying by positive 1. And multiplying anything by 1 does nothing. So at this point, identify your like terms. We have x squared terms, we have x terms, and we have constants. 1x squared and 2x squared is 3x squared. 4x, negative 6x is a negative 2x. Negative 2, positive 9 is a positive 7. We took this trinomial plus a trinomial and simplified it down to just one trinomial, combining like terms. Now here's where this first step, distributing the sign, becomes important. A positive out front, we could think of it as a positive 1. Doesn't do anything. So we have 4y squared and a negative 2y. But for this second set of brackets, we have a negative sign out front that needs to distribute to each term. If we think of that as a negative 1, multiplying by a negative changes the signs. So negative 1 times 3y, my 3y squared now becomes a negative 3y squared. Negative 1 times 5y now becomes negative 1 times positive is a negative 5y. So it's distributing the negative sign. We see it starts to change signs. That's where you have to be careful. Once you've distributed, identify like terms. 4 and negative 3 is a positive 1. Negative 2y and a negative 5y is a negative 7y. Best way to write this, coefficients not necessary, y squared minus 7y. Simplified form. So you can give this one a try real quick, stop, give it a whirl, and then we'll talk about it. Here's what it looks like. Positive 1 in front, negative 1. We need, well, positive 1 distribute doesn't do anything. If you want to put that 1 in front to work with it, go for it. But now when we distribute negative or negative 1, 7a squared times the negative becomes a negative 7a squared. 4ab times the negative becomes a negative 4ab. Negative 2 times a negative. Negative times a negative, there's a positive 2. So at that point, 6 and negative 7 is a negative 1a squared because they're like terms. My AB terms are like because it's an A and a B, and this is also an A and a B term. Negative 1 and negative 4 is negative 5 ABs. And then positive 4, positive 2, those are my constants. They just stay as a constant of 6. Best way to write this, don't need the negative or the 1. We still have the negative a squared minus 5ab plus 6. There's your simplified form. Last one to take a quick look at is if you now start to put monomials in front of the brackets. Well, we're still going to distribute the sign, but what we have to add to this is we distribute the sign and the monomial that are in front. So if you take a quick look at this, how many multiplication steps would there be to get rid of brackets? Well, positive 4 needs to be distributed twice. Positive 1 needs to be distributed twice. Negative 2 needs to be distributed 3 times. And note that it's a negative 2. So what are we left with? 4 times 2x, 8x's. 4 times y is 4y. 1 times 3x is a 3x. 1 times negative 2y is a negative 2y. Negative 2 times positive 5 becomes a negative 10x. Negative 2 times negative 5y is a positive 10y because a negative times a negative. And negative 2 times positive 2 is a negative 4y squared. Note that when we distribute, we are eliminating brackets. The whole point to this process of distributing, when we multiply, we're getting terms, but we're getting rid of the brackets. Negative 2 times all this gets rid of the brackets. Now we just have a bunch of like terms that we need to combine. So, which ones are like? Well, we have x terms, a whole bunch of them. We have y terms, and we have a y squared term. Note that y terms are not the same as a y squared. Like terms have identical variables with identical exponents. This exponent 2 makes that term unique. So what do we have? Start with the biggest exponent term. We have a negative 4y squared. We have 8x and 3x is 11x. 11 minus 10x's is a positive 1x. Don't need the coefficient 1 though. And then we're left with 4y, negative 2y, which is 2y plus 10, leaves us with 12y. There's your simplified form. Again, you could write this all kinds of different ways as long as you have those 3 terms with the correct sign. That's what's important. We need to make sure that no matter what 3 terms you have a positive x, you have a negative 4y squared, and you have a 12y positive. All kinds of ways to write it. All acceptable. Just make sure you have the right stuff in each situation. So from there, here's your assignment. In the booklet, you have page 10 and page 27 from the booklet. Page 10, answers are there. Page 27, answers are afterwards. You can find the answers in the booklet. Page 27 has a lot of questions on it, in it. Do I expect you to do all of them? No. But again, the best thing to do is to practice. You have time, folks. So enjoy, get this done, and we'll talk in a few days. Couple days off, get this done, practice, and then in a couple days I will post your next lesson. Have a great day, folks, and a great weekend. Take care.